So this is problem 416 in your book. And we're supposed to find the reactions at the pins on the beam shown. The first thing we need to do is to turn those distributed loads into point loads. Alright? So now let's draw this beam with those loads on it. Alright, so the 2 kips per foot is spread over 16 feet, so I do 2 times 16 to get 32 kips. And that's going to act at the center of that rectangle, which will be 8 feet. So now I take the 1 kip per foot load, and it becomes a 26 kip load, and it's going to be at the center of the total length of that rectangle, which it's 26 feet, so it's going to be at 13 feet. Okay, so now let's start with what we know. We can write the sum of the forces X is equal to 0. Alright, and I haven't drawn my reaction forces in, so I need to do that so you can see them. And that's going to be RAY, and then that's going to be RAX, and I'm going to draw them in and label them. I draw the directions arbitrarily. That's RBY. Okay, so now let's go back to our equation, sum of the forces X. So we have RAX is an X force, but it's the only one. So what we see then is that RAX is equal to 0 for this one. Now let's write the sum of the forces Y. They're also equal to 0. So we have RAY plus RBY minus 32 minus 26. So then we have 0 is equal to RAY plus RBY minus 58 kips. So let's solve for one of the variables, and when we do that we have RAY is equal to 58 minus RBY. Okay, so now we need to write the sum of the moments equation. Remember that the counterclockwise moment is positive, and so let's write the sum of the moments about A. Alright, that's at the pin connection. Because we're at the pin connection, RAY and RAX won't be a part of the calculation because there's no perpendicular distance. So the first force we have to consider is the 32 kips, and it's 32 times 8 feet, and that's going to create a negative moment, so I put a negative sign, minus 26 feet, I'm sorry, 26 kips times 13 feet. Plus RBY, now that's going to be a positive moment based on the way I drew RBY, times total length of the bar, 26 feet. Okay, so now I can solve this for RBY. So we have 0 is equal to negative 594 kip times feet plus RBY times 26 feet. Now I'll move the 594 to the other side and get positive 594 kip feet is equal to RBY times 26 feet. So that works out to be RBY is equal to 22.84 kips. Right? So now I can go back up to my earlier equation and get RAY. It was 58 kips minus RBY. So I do 58 minus 22.84. And I get 35.16 kips. So now I have RAY, RBY, and RAX. So just draw those back in on my diagram. And that's the final solution to this problem. All the numbers came out positive, which means the directions we assumed were correct.